This is Math 7, Unit 7, Lesson 2, the first part. Introduction to Probability and Likelihood. We're also going to be completing the Spinners worksheet. So it is available through Canvas, or if you picked up the packet from the school, it's available there. I think it's the second page. Okay, first, probability is a number between 0 and 1. Inclusive, so it includes 0 and 1, or 0% and 100%, that measures the likelihood of an event. So here at the top you can see probability can be represented as a fraction with increasing likelihood going from 0 to 1%. It can be measured using a decimal number, and you can use percentages to represent probability. Okay, likelihood. Likelihood is represented using, it's a phrase. The likelihood is a phrase that describes how likely something is to happen or not happen. So right here, it includes all these words. If something has a probability of 0, it is impossible. If it's a little bit above 0, but not exactly 0, you might call it unlikely. Almost impossible, very rare, rare. All of those are common phrases that are used to describe something that is unlikely. As you move to being more probable, you get more likely than unlikely. Right in the middle is equally likely as unlikely. There's a lot of phrases that get used in everyday lingo, like 50-50, sixes. That's kind of an old one. You may not know what that means. Or someone might refer to it as a coin toss. Oh, that's a coin toss. As you move up the probability scale, you get to a likelihood more likely than unlikely. That means something is more likely to happen than not happen. We've got likely up towards the top end. There are some common words like common, very common, and almost certain. I guess common really is more of if something's common, a large percentage of the population tends to have that happen or be the case for them. Maybe ubiquitous. And then as you get over to a probability of 100%, that would be something that is certain. Let me go over a few examples with you just to give you an idea of this continuum. Something that is nearly impossible, I didn't put an impossible thing here, is for you to win the lottery. Slightly more probable, but still extremely unlikely, is having an airplane crash on top of you. But it is more likely than winning the lottery. Next, we move up a little bit. Rolling a 1 on a standard 6-sided die is unlikely. Now, if you do it a few times, you'll notice it will happen. It's got a probability of 1 in 6, 1/6, which is about 17%. So it is unlikely, but unlikely events do occur all the time. Okay, moving up a little bit. This is more unlikely than likely. If you don't have anything protecting your phone and you drop it, it breaking, like the screen getting cracked, that's why it's good to have protection on your phone. Move up to almost 50%, being born a girl. Now, statistics, if you look throughout the whole world, and it varies from country to country, and there's some theories for why it is, there are more boys born than there are girls born. One theory that I like is it's an evolutionary thing, that young males are more likely to get into some sort of accident and not make it to adulthood than young females are. So it could be something biological there. But there are a lot of theories about why that is. It's really close to 50%. It's probably like 49.5% in the United States. And in a place like, I think China's about the highest male percentage. I think it's still around 45 to 47% there. All right, right at 50% would be flipping a coin and getting heads. As we move up, being bullied at least once. I give that about a 70% chance. Graduating from high school currently is around 80 to 83%. Last time I looked it up, it could be different now. That was a couple years ago when I looked that up. This is an interesting one. This is actually referred to as the birthday paradox. If you have two people with the same birthday out of 30 people. So if you have a classroom of 30 people, you have pretty close to a 90% chance that at least two of them will have the same birthday. And that sounds counterintuitive because there are 366 different birthdays you can have, well, including February 29th. So it seems counterintuitive, but it's actually a very high probability. Okay, another one, you waking up tomorrow. Most people will. Very few die in their sleep, especially at a young age. That would be even less common. And if you drop a coin and gravity pulls it down, that's pretty well certain, at least right here on our planet. Gravity pulls everything down. Now, it doesn't mean that it'll pull it all the way down to the ground. If you drop a coin right on top of a desk, the coin will hug the desk. It'll be pulled down by gravity. It just won't go any further because the desk is in the way. Okay. All right, so this is the start of the worksheet we're going to be discussing in this video. The purpose of this worksheet is to get you to come to understand likelihood a little bit better. So you spin the spinner shown. Is spinning a vowel equally likely to happen or not happen? Explain your reasoning. So we need to look at this spinner. The vowels include, there are two A's and a U. Okay, that gives us 5 vowels out of the 8. Is 5 out of 8 equally likely to happen or not happen? Actually, I'm going to go with no on this. Because, well, 5 out of 8 is, what is that, 62.5%? It is actually likely, or more likely than unlikely. It is more likely to happen than to not happen. Not equally likely. Okay, number 2. Give an example of an event that is equally likely to happen or not happen. Okay, there's a lot of good examples. I like coin tosses. Theoretically, a couple that is pregnant is equally likely as unlikely to have a boy or have a girl. Now, I did mention it's slightly off 50%. That's why I said theoretically, because there's 2 outcomes, each considered equally likely. All right, so a good example there. What's equally likely to happen or not happen? We're going to flip a coin. Actually, I think this refers to the spinner. So let's do something based on the spinner. How about we spin a shaded region? Yeah, because then we could get the E, A, U, or T. So spinning a shaded region, there's 4 of them out of the 8, which is 1/2, which is 50%. So yeah, if you can get a 50-50 chance, that's your equally likely as unlikely. 3, give an example of an event that has a probability of 100%. Okay, looking at this spinner here, something that has a probability of 100% would be, well, each section has a letter on it, so we want this to be guaranteed to happen. So we're going to say spinning a letter. Because then EVALUATE, evaluate, either of those letters, if you spin it, it is spinning a letter. Let's give an example of an impossible event. Okay, looking at the spinner here, if I spin it, an impossible event is just going to be spinning anything that is not there. So we'll just pick something here. Spinning a J. Spinning a J is not going to happen because there are no J's on that spinner. So it is an impossible event for this situation. Use the numbers to complete each spinner so that it corresponds to each described event. The probability of spinning an even number is 1. Okay, a probability of 1, we need to realize what that means. Remember that a probability of 1 is certain. So we need this spinner to be created so that it is certain that we get an even number. That just means every one of these blanks need to be filled in with an even number. Now I could just go 2, 4, 6, 8, but I don't have to continue increasing, and I can even make some other really big numbers. It doesn't matter how big or small the number is, it just needs to be even. So I'm just going to throw a few numbers in here, and I've got the numbers 2, 4, 2, 162, 8, 16, 22, and 34. If I spin this spinner, the probability of getting an even number will be 1. It is certain that we will get an even number. Okay, number 6. The probability of spinning a multiple of 3 is 0.5. Now let's assess this, 0.5. That's the same as the fraction 1/2. So that means half of these sections need to be multiples of 3. And the other half would have to not be multiples of 3. Because if we had more multiples of 3, it wouldn't be a probability of 1/2. So, multiples of 3. 3 and 6 are both multiples of 3, and so is 33. There you go. So I've got 4 sections that are multiples of 3. The others need to not be multiples of 3. Things like 1, 2, 7. What's another good one? 10. Those 4 numbers all have 3 not being a factor of them. So for this spinner, the probability of spinning a multiple of 3 is now 1/2. Only half, or 4 out of the 8 sections, contain a multiple of 3. Okay, let's look at the next one. Spinning a 4 is unlikely. All right, we need to think about what unlikely means. Let's go back here a couple of pages. If something is unlikely, it needs to have a probability less than 50%. And it can kind of venture into this region, but probably more staying down here, 25% or below. So we want it to be unlikely. Now let's think about this. If we have 8 sections, if none of them is a 4, then it's not unlikely, it's impossible. So we need to have at least 1 4. All right, can we have 2 4s? By the way, does 1 4 work? Yeah, 1 out of 8, that is unlikely. Would 2 4s work? That gets us up to 25%, 1/4 of them. And that would also work. If we do 3 out of 8, that's 37.5%. That's still on the unlikely, so you could have 3 of them filled in with 4s. If you fill 4 of them in with 4s, though, it is no longer unlikely. It would be equally likely as unlikely. So I'm going to go ahead and put a couple of 4s on there and make the rest of them be a different number. I'm going with mostly 5s. It doesn't really matter what number you use. So in this spinner, I have 2 4s and the rest are not 4. So it is unlikely when spun that I will get a 4. Unlikely, it still needs to be possible. Unlikely cannot be the same as impossible. Okay, number 8, spinning a number divisible by 5 is likely. All right, if we want it to be likely, it needs to be more than half. Remember that at 50%, likely is in this region. So we just need there to be more than half of them divisible by 5. Numbers divisible by 5, they end in either 5 or 0. So we're looking at, the multiples of 5. So throwing some of these in here, we need to have at least half of them be multiples of 5. Oh, 6 isn't a multiple of 5, but I can get more multiples of 5 here. Let's go with 10, 100. How many multiples of 5 do we have so far? There's 1, 2, 3, 4. So we need at least 5 for it to be likely. rather than equally likely is unlikely. Let's make this one 20. Okay, we can fill in the rest with anything we want. We've already got a not 5, so whatever these end up being, it'll be okay. That gives me 5 out of 8, which is likely. I could have done 6 out of 8 being multiples of 5, or 7 out of 8. 8 out of 8, though, wouldn't work because that would go from being likely to being certain. Okay, quick review of ratios. We're going to be using ratios in part 2 of this lesson. We're going to write the ratio in simplest form. What's the ratio of baseballs to footballs? Okay, baseballs, there are 2 of them. Footballs, there are 6 of them. Let's go ahead and write that as a fraction. Okay, it's a ratio of 2 to 6. It wants it in simplest form. We can divide top and bottom by 2 and get a ratio of 1 to 3, or 1/3. Okay, footballs to total pieces of equipment. I'm assuming they're referring to all 8 of these as pieces of equipment. Maybe they should have just said sports balls. Anyway, there are 6 footballs to the 8 total sports balls. And that gives us 6 out of 8 as our ratio, or fraction. If we reduce that, divide top and bottom by 2, we do get 3/4 as our ratio. Okay, sneakers to ballet slippers. There are 2 sneakers and there are 4 ballet slippers. Say 1, 2, and 1, 2, 3, 4. This gives us the fraction 2/4. And that does reduce to 1/2. There is 1 sneaker for every 2 ballet slippers. Okay, sneakers to total number of shoes. There are 2 sneakers, and ballet slippers, I guess, are a type of shoe. So there are 6 total shoes there. 2 to 6 becomes the fraction 2/6, and that reduces to 1/3. So you could say 1/3 of these shoes are sneakers. Okay, green beads to blue beads. On this, the ratio, I see 3 green beads, 1, 2, 3. And blue beads, I see 1, 2, 3, 4, 5, 6. So it would be 3 to 6. That would be 3/6, and that reduces divide top and bottom by 3 to 1/2. Red beads to green beads. I see 4 red beads, and green beads there are 3. This becomes the ratio 4/3. Now we won't get probabilities greater than 1, but we can get ratios greater than 1. Okay, number 7, green beads to the total number of beads. Well, I see 3 green beads, and total number we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is 3 green beads compared to 15 total beads, or 3/15, which dividing top and bottom by 3 gives us a ratio of 1/5. 1/5 of the beads are green. Okay, this is the end of part 1. Please stay tuned for part 2, and thank you for watching.